Hi, it's Professor Monty. Let's look at a total value or often a ticket word problem. We're using systems of equations because we're going to have two variables. Okay, so tickets to the play cost $12 for adults and $5 for children. If 300 tickets were sold for $2,620, how many of each type of ticket were sold? Okay, so first thing, let's name our variables. That's always the first thing you want to do. We're looking for each type of ticket. So we're going to say let X equal number of adult tickets. And we're going to let Y equal number of child tickets. Now, this type of problem can also be done without a system of equations, just a single variable, but we're doing this as an example of systems of equations. It makes it much easier to do it with two equations, two variables. Okay, so we've got that. Now, one of the equations we're going to have, and we have to have two equations because we have two variables. One of the equations has to do with the number of tickets. The other is the amount of money. So let's think about number of tickets. If we say X plus Y, that's the number of adult tickets, plus Y, the number of child tickets. We know that was 300 tickets. So that's number of tickets. All right, I'm actually going to erase that. I don't want that there. And then the other one, we'll just put number here. And then the other one is the money. So let's think about the money. Well, the total value of the adult tickets is $12 times the number of adult tickets. So it's going to be 12x. Plus the child money is $5 plus the number of child tickets. So 5y. And that's going to be my 2620. All right, so that's the idea. That's my setup. Those are the equations. Now we're just going to solve these. Now, the easy way to solve these, I'm just going to multiply both sides by negative 12 up here to get a negative 12x. Oh, even easier. We'll multiply by negative 5. Because now I get a negative 5y to add to the 5y. Those are going to eliminate or cancel. So let's multiply both sides of the equation here by negative 5. I'll get negative 5x minus 5y equals negative 1,500. This one I'm just going to move straight across. I'm not going to multiply by anything. 12x plus 5y equals 2620. And now I'm just going to add down. So I get 7x. The y's cancel. And I get what? That's going to be 1,120. And now just divide by 7. I can figure out what x is. All right. Use my handy dandy calculator here. So I go 1120 divided by 7, and I get 160, which is the number of adult tickets. And so what I'm going to do is I'm going to take that. I can plug that into either equation and solve for y. Obviously, it's going to be easier if I plug it in here. And so that equation is just going to become x, which is 160, plus y equals 300. Subtract the 160, and I get y equals 140. So I'm going to answer it in terms of the problem. Though x is number of adult tickets, 160. Y is number of child tickets, 140. And then what I would suggest, we'll box that so the teacher knows that's my answer. Plug those in, make sure they work. So plug them into both equations. I know the 160 plus 140 is 300. Plug, let's use the calculator. 12 times 160 plus 5 times 140. And I get 2,620, which is true. I know that's the correct answer. Everything makes sense. So I've solved the problem. So practice these. This is a classic type of application you're going to see in systems of equations. So name your variable, find your equations, and then either use one of your methods, the substitution method, the elimination or addition method, whatever works out best for you and for the setup of the problem.